Hello everyone, welcome to this video. My name is Emerson Ahrari, I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to do a snowmelt monitoring using Aero5 data in the Google Earth Engine code editor environment. In the first step, you must find your region of interest. This tutorial can be used for all around the world and not only limited to one location or one specific date. So, for example, in this tutorial, I'm going to select one region from high latitudes. For example, I'm living in Finland and I'm going to select a basin in the northern of Finland and compare the snow melting process in a couple of years. So, for example, through the marking tools available here, mark your region of interest. Then you must find the border of the basins covered this region. Go to search places and dataset, type hydroshed basins. As you can see, hydroshed basins from level 1 to 5 is available. From 1 to 12 is available. Typically we use level 5 basins. Import it into the code and then we must filter the table or filter the basins based on the geometry. Make a new variable as ROI equals to ROI means region of interest. ROI equals to from input table filter based on the location of the geometry. The marking the region we marks using the marker from drawing tools available here. So then to do simplification, we must use a simplify function through the function and loop structure here. Make a function, each input feature comes and returns while it is simplified. Feature dot simplify, just like that. One argument here is the maximum number of errors. For example, 1000 degree is the level of simplification. Higher number, higher simplification, lower number, lower simplification. To do the visualization, use a map.add layer, just like that, to see the border of the basin. And if you want to focus on the basin through the center object, you can focus on region of interest. If you run a code, after a few moments, you will have focus on the study area already marked and simplified. So, after region of interest selected, and also it should be noted that the hydroshed basin layers in all scales available globally, and you can use this tutorial for your own region of interest. And there is no limitation in the data and period of time I'm actually teaching here. So now we want to use temperature and snowmelt data from Aero5 dataset. Go to search places and dataset here, type for Aero5 land daily aggregated product. As you can see, Aero5 land daily aggregated product is available here. Import it into the code. Click on the link to get more description or information about the product you want to use. As you can see, this wonderful product is available since 1950. It is an assimilated product that is a combination of satellite data, models, and also in situ data that's highly recommended for the climatological studies and also freely available for all around the world. If you go to the bands here, you can find various bands or various information available that could be very, very helpful for environmental parameters and climatological parameter studies. Its spatial resolution is around 10 kilometers, that is enough for climatological and environmental data in a global scale. So, and now, this product already entered into the code as an image collection, and then here, as you can see, one of the bands refers to the temperature, the air temperature, the temperature near to air near to the surface with 2 meter height. So here temperature in 2 meter should be temperature of the air at the 2 meter above selected, and then make a variable as temperature equals to bring the image collection, arrow file collection first, select the target band. The target band was temperature 2 meter, and then throw the filter date, select your time span, the period of time you want to do a study for a snow melt monitoring. For example, I'm selecting a period of time since 2015 to 2018. This is an example. You can use the filter date, for example, any period of time starting from 1950 to 2024, the date I'm producing this tutorial. So, as you can see here, this product is available, the temperature data is available, but according to the data description and the unit information, the temperature at 2 meter, its scale is Kelvin. And if you want to convert it from a Kelvin to degree Celsius, we must make a function to do a single calculation for each available data to convert it from Kelvin to degree Celsius. Make a function, each input layer considered as an IMG here, and function returning each input image while it is subtracted from 273.15. This is a constant value useful to convert from Kelvin to degree Celsius. With the properties the image already had. Property names. The property names allows us to copy all the existing properties or metadata information from the input to the output here. So now I'm gonna actually make a plot that shows when temperature goes above 0 degrees Celsius. That is one of the most important criteria for the snow melt process study. So make another variable, or you can do it using the print. Throw the user interface, chart, image, series, DOI series by year. Here you can actually visualize the temporal variations of temperature based on day of a year and compare it from one year to another year. This is one of the useful chart series, allows us in the Earth engine compare different variation of different parameters in the Earth engine, specifically when we are dealing with days available for a couple of years. Instead of image collection, and you can see all the properties listed here, instead of image collection, we have the temperature layer and the band name, the target band, temperature 2 meter, region of interest already defined through the region of interest or ROI. So here we have two reducers. The first one, reducer for the region. We want to aggregate the data based on the region of interest. In the aggregation, you can use a statistical operator available through the reducers. For example, if you want to get the average of the region, you can use Earth Engine reducer .min. Otherwise, you can get max, min, or any other statistical parameter you prefer. For example, Earth Engine reducer .min allows to aggregate average value for the whole of the region. If you want a max for the whole of the region, then you can turn it to the max. It's totally up to you which kind of a statistical operator you want to use. The scale refers to the spatial resolution. As this product is 1000 meter spatial resolution, then 10,000 meter is the target resolution here. And day reducer, if we have a couple of images per day, we can aggregate them using a statistical operator again. It should be Earth Engine, it should be based on the average by default, Earth Engine .reducer .min by default. And the chart starts from the first to the end of a year, the day number starting from 1 to 365, and now you can compare the temperature variation for each year separately. Click on Save and Run again. After a few moments, in the right panel, you will have a new plot that shows temperature variation over a year. That could be very useful to compare how temperature changes from one year to another year. So as you can see, chart is under generation. After a few moments, you can see the chart. If you have any problem regarding to the code, it should be noted that the code example is available below this video on my YouTube channel, and you can reach me out there and pick up the code link available there. So, and here as you can see, we have three categories, 2015, 16, and 17, that shows the temperature variation from the first to the last of the days. And here you can compare in which day of a year temperature was, for example, higher or lower in different years. It's a very, very useful chart to compare variations based on day of a year. So as we want to working on, let's say, a snow melting process, it is important to select or limit the time span to the month that temperature going up. For example, here we based on a calendar Earth engine that filter that calendar range. I can limit I can actually filter my data to the target months in which the melting process typically starts, at least in Finland, and you can change the calendar range months based on your study area. For example, I'm gonna limit it from the March, actually month number 3, to actually the June month number 6 here, and the field will be month. Here you in the right panel, your chart will be updated based on these months: March, April, May, and June. And also, so this is the transition period that temperature comes above 0 degrees Celsius for consecutive days, as you can see here. For example, as you can see in 2016, from day 118, temperature comes above 0 degrees Celsius continuously, and also never drop down, and shows that in 2016 we have a temperature raised earlier compared to 2015 and 2017, as you can see. For example, in 2017, the red line you can see from day number 137, temperature goes above 0 degrees Celsius continuously and never drop down. So such kind of threshold and such kind of monitoring could be very, very beneficial for the snow melting process prediction, because as you know, the temperature is one of the key factors in a snow melting process. But remember that the snow melting process not only depend on the temperature, there are a lot of parameters and criteria which can have impacts on the snow melting process. But here, if you fix the other thing, if you set fixed, if you keep the other parameters fixed and only pay attention to the temperature, here you can see such kind of plots could be very useful to interpret the results. So this is about the temperature side. But what if about the snow? How we can see how much the snow melting process varies from one year to another year? If you go to the Era 5 data properties here, you can find a band specifically designed for the snow melting process. Go to the data description again, and after a few moments here, you will have access to the data description and information available here. Using Control F, you can search on the page about a snow tag here, and as you can see, various bands available about the snow with snow prefix, snow depths, snow cover, snow albedo, snow depths, and one of them is snow melts, or even temperature of the snow layer. All of these wonderful data products allows you to get more information about the snow characteristic and snow condition in different dates over a year. So for example, I'm gonna have a snow melt values. So make another variable specifically used for the snow melt here. Make another variable as snow melt equals to from input image collection. From input image collection, select the target band that is the snow melt and filter your data based on the same period we already have in the temperature data, starting from 2015 and ends to 2018 here, just like that. So no need to change the range of the values because it's already if you go to the data description here, there is no scale factor for such kind of data. If you want to get information about the units here, the unit column is available and can help you in this regard. So make another chart, this time for the snow melt. User interface, chart, image, that's DOI series by year, because we want to compare different years. That's why DOI year used. If you want to compare different region, DOI by region could be used. So a couple of arguments we will have here. Instead of image collection, we must have snow melt variable. The band name is snow melt sum. Snow melt sum already mentioned. Region of interest equals to ROI. Region reducer, Earth engine that reducer, that mean, just like that. And the scale value should be 10,000 or 11,000 based on a spatial resolution. And day reducer, as I mentioned, if you have a couple of images for each day, the reducer helps you to convert them into a single image. Earth engine that reducer, that mean by default used. So the start date and end will be 1 and 365. And as we want to compare the temperature and the snow melt value, it is necessary to use the same calendar filter for starting from March and ends to June. That filter, Earth engine, that filter, that calendar range, as you can see here, starting from March to June. And the field must be months, just like that. Run a code again. So the snow melts. The word is wrong. Snow, not same as the name of the variable. Snow melts. Again, run a code. After a few moments, you will have another chart, two charts available here, one of them for temperature and another one is about the snow melt process. The higher value, higher snow melt, lower values, lower snow melt. For example, the yellow color in both charts related to 2016. As you can see, in the 2016, in the day 118, actually we can see the temperature goes above 0 degrees Celsius continuously. And also because before 118, you can see for some days the temperature dropped down. And as you can see here, the highest snow melt process occurred in the day 118. But before this date, snow melt already started, because as you can see, temperature raised above 0 degree for a couple of days. Here you can see it's we can say that it's started from day 85, and here you can see from day 88 the snow melt process actually started much earlier compared to the other years, 2015 and 2017. But in the 2017, for example, here you can see the temperature raised above continuously in day 137, and here you can see the almost the highest value, and the main peak for the snowmelt process started from the day 138. That could be very important information that help us to find the relationship between the temperature and snowmelt process. And another year, 2015, you can see already temperature raised above zero from day 88, and here you can see around day 90 the snowmelt process started, but the peak is day 127, and as you can see from the day 126 the temperature starts to raise continuously, goes above during the time. As you can see, this is a very helpful comparison for different years to see that how much the snowmelt process shifts from one year to another year based on the years we have here. So, and if you want to actually find the images for each period of time, and also before we go through that, it should be mentioned, if you click on each link available here, you can get the CSV file or a PNG file for each plot, and you can use it in your research works, papers, and also the commercial purposes. And this can be done for snowmelt and also the temperature data. But remember that if you want to find the relationship between the days number and the date information, here you can add some extra information to the properties available here. So let me to get a print from the data first. And now I'm gonna get a print from temperature data first to show you what kind of metadata or what kind of information do we have here. If you go to the properties means the properties here is related to the properties related to the is some sort of metadata information, including necessary information for each data will help us to get understanding about the acquisition date or other necessary information. For example, if you go to the properties here, you can find the day number, month, and also the year, and also that could be very helpful to understand the relationship between DOI and also the specific date. But here I can actually add two new properties. One of them is about the date with normal format, and another one is about the DOI, and another one is day of a year. So for example, here the date, I can make a variable as date allows us to calculate the date with the normal format here. From each image, I'm gonna get the date information using the date. So, and then acquisition date equals to get the date first and convert it to the string format with the normal structure, including year, month, and the day. So, and now I'm gonna have the acquisition information as a new properties. When you want to make a new properties, that set is a useful function. That set acquisition date or date. It's totally up to you what kind of names or phrases you use. So here acquisition, and the next one is, for example, DOI. From the input day, I'm gonna calculate the day of a year. So get relatives is another function, allows you to find the day of year, just like that. But as it is starting from 0, it should be added to 1, because it is started from 0 and returns 300, returns from 0 to 364 days instead of from 0 to 365. That's why we need to add to one extra value. So, and another property should be DOI, day of year. DOI will be like that, day of year. Sorry, I is wrong. DOI is a kind of actually a name that we use for the paper address or something like that. Day of year, DOY. DOY equals to DOY again, and run a code. In the new image collection, you will have two extra properties. One of them is date and another one is DOI, that helps you to understand which DOI refers to which date information. As you can see, the date information shows this image belongs to March 8, 2015, and also the day DOY shows this image related to day number 67. That's very, very helpful things to understand, to get more understanding about the kind of data we are working. So here we can have these actually variables for, we can have these variables for snow melt, make a loop function just like before. Each input image considered as an IMG here. Sorry. Copy and paste it. Here again we have date, acquisition information, and DOI. Let's copy input properties first. Copy properties first. img.property names, and set the new properties as mentioned, as it pointed out before. Yes. And let's get a print from snow melt data. So as you can see, we face an error here. It's about line 38. Gates relative is not a function. The problem actually back to return issue. Remember to make, whenever you make a function, it is necessary to have a return function as a final result. But the return means here the IMG should return with the new properties. Run a code again. Hopefully problem is solved, and after a few moments here you can have temperature and snow melt data with DOI and date information. So for example, for 2000, for example, regarding to the temperature data, for example, the day 118 is the date or a specific day in which temperature goes above 0 degrees Celsius continuously and never drop down. And now you want to know that what is a day 118? It refers to what kind of date or which date in a year. So it's very simple. Here you can filter your data based on temperature already printed here, Earth engine.filter.equal as the number of day of year already calculated as a new properties. We can filter our data based on. So DOY, I'm gonna find that image in which DOY equals to 118. So run a code again. And as you can see, 3 elements returned. Why 3 elements? Because we have 3 years, 2015, 16, and 17. But the target year is 2016. So, and here we can have another filter, this time for the year. That filter Earth engine, that filter that calendar range. The calendar range, you can say, okay, the target year is 2016, and just return this image for me. As you can see, we have 1 element So with one image, and 118 refers to April 27, 2016. This is the main date that temperature goes above 0 degrees Celsius and never dropped, and this is the key date in which the melting process starting significantly here. Or here you can see the 118 is a date that snow melting reached to the peak. And for example, for another years and also another parameters, you can get such kind of actually queries easily and without any problem. If you have any problem and issues about the code, I highly recommend you to compare yours with mine. My code link is available below the video on my YouTube channel, and you can compare mine with yours. And if you face with another issues in the programming in the Earth Engine, feel free to reach me out on YouTube channel and put your comments and share the tutorial, please. Thank you for your attention.